Hi. In this video, we are going to dive into the introduction to reactor design. Now, this is the part where you actually start talking about reactors and not just about the mathematical expression of the rate equation to describe the progress of the reaction. Okay, the, but for a brief recapitulation, the rate equation for a component I, or a reactant to be more specific, reactant I is denoted as Ri equals to 1 by V dNi dt. And this change in moles of I with respect to time is uh, as seen during the progress of the reaction. Okay. Now, intuitively, you can understand that this rate of reaction is heavily dependent on the conditions within the reaction volume. Okay. And this is, as you can see, a differential expression. But when we are practically going forward with reactor design, let me just highlight it with a different color. So when we talk about reactor design, we specifically want to know size of the reactor, type of the reactor, and mode of operation. Okay. Now, if you just consider a reactor as a vessel, so I am considering a reaction vessel. Okay, I'm not going into its size, I'm not going into its type or operational mode. I'm just talking about a simple vessel where a reaction is occurring. So to describe the progress of reaction or the condition within the reactor very well, we need to know about the position as well as the time. So there is a space coordinate and there is a time coordinate that you need to consider. Now, again, depending on the temperature and composition of the reaction, uh, these conditions may vary from point to point within the same reaction volume. Okay, for real world applications, and this greatly depends on whether your reaction is endothermic, whether it is exothermic, whether there is any cooling involved, and if there is any flow through the so a lot of factors are at interplay. Okay, and therefore uh, these are the factors that we need to keep in mind when we are talking about reactor design in general. Now, in case of homogeneous reactions, they are usually operated in the following types: batch, steady state flow, and unsteady state flow or semi batch. So these are the general types of, you know, reactors that you can see for homogeneous reactions. Okay, now just I'm going to briefly outline the features of these types of reactors. So let's start with batch reactor. Batch reactor is very much similar to this reaction vessel that I was talking about. Okay, so it is very simple and it has very less requirement of any supporting equipment. Okay, supporting equipment, and it is very well suited for small scale production. Okay, also if you have very like very subtle processes going on, very small amount but very sensitive materials to work with, then you would generally prefer a batch reactor. Okay, now the next type is steady state flow reactors. So this is a very common type of reactor seen at the industrial scale. Okay, and the best part is that it operates at a steady state, and you of course you will need supporting equipments, so there is a requirement of supporting equipments, but these are extremely efficient and very easily operated in the, like with the ideology of automation and so on. Okay, so that is one of the very attractive features of steady state flow reactors. And also the product quality control, this is a very important factor. Product quality control is relatively easy to achieve. Okay, and this kind of reactors are very widely used in oil industry. Batch reactors are widely used in pharma industries or food industries and so on. Okay, also in case of specialty chemicals, these batch reactors are very prevalent. The next type is a semi batch reactor. So in a semi batch reactor, this again is seen in either of the categories, like for industrial scale operation, also for small scale operation also. The idea is that this system is flexible. Flexible meaning, let me just draw a diagram and show you. A batch reactor is like a vessel. Okay, I'm drawing a very small diagram over here. So you have added all your reactive constituents and you are just reacting. After the reaction is over, you can take it out. For the steady state flow reactor, let's say you have a tubular reactor with some bends. So, throughout the length of the tube, the reaction occurs, and the composition at any point remains unchanged with time. But within the batch reactor, the composition will change. It is a dynamic system, it changes with time. But over here, it achieves a steady state. Okay, this is for a steady state flow reactor. But for a semi batch reactor, so you have a reaction volume. Let me draw a circular reactor. So you have a reaction volume, but you are also adding one of the reactants later. Okay, so here we have reactant A, here we have reactant B, and the volume and composition changes within this system when you are adding the other reactor. So this is a semi batch reactor. It's not fully batch because you have not added everything all at once, but you are adding it at given intervals. So this becomes a semi batch type of reactor, and this offers very good control. Control on what? On the reaction speed, because you are adding the reactants as required. Okay, so you can see a lot of semi-batch reactors, especially in the steel production processes. So, like in steel production processes, we have open hearth furnaces. So they are basically modules of semi batch reactor. So open hearth furnaces, you add your reactant and then you produce the steel. So depending on how your reaction is progressing, you add more of the raw material. Okay, so this is the basic understanding about the different type of reactors. Of course, I have spoken about ideal reactors in another of my lectures, which you can find in this playlist. But overall, to be very brief, this are the main types of reactors: batch, steady state flow reactors, and semi batch reactors. That is it. Thank you.